Hello friends, let us discuss about the Paulings's valence bond theory. Last lecture we have seen about the tetrahedral complexes as well as square planar complexes. When the square planar complexes undergo DsP2 hybridization, when we discuss the bonding. Here we take one example, NiCN4 raised to 2 minus ion. Here are the 4 cyanide ion which are bonded to the central metal nickel ion, and charge on the 4 cyanide ultimately 4 minus charge. Then what is the charge on nickel? Here we have to take the 2 plus charge on nickel minus 4. The overall charge is equal to minus 2 in this complex ion. Nickel having the atomic number 28, its ground state electron configuration and valency shell is 4s2 3d8 in the free ion state. Then nickel is converted into Ni2 plus, having a loss of 2 electron from 4s. The electron configuration is 4s0 3d8 in the free ion state. In the ground state configuration of this ion having the 3d orbital 4s and 4p orbitals, we can feel the electron in the ground state of Ni2 plus is 8 electrons, 1 2 3 4 5 6 7 and 8 electron. The 4s and 4p orbital are vacant. We need 5 that is the remaining orbitals for the occupation of the electrons of the cyanide 4 cyanide ion. Here this electron of nickel 2 plus ion will go into the previous orbital for the making a one orbital vacant for the electrons of the cyanide ion. So we can fill the electrons of 4 cyanide ions into 3d orbital, then 4s orbital and 4p orbitals. Two pair are paired into the p orbital. So one pair, second, third and fourth pair of 4 cyanide ions are occupied in respective orbital, and it undergoes the dsp2 hybridization. When we discussed about the dsp2 hybridization, the central atom is present at the center and 4 cyanide ions are occupied by 4 corners of the square plane and undergo the square planar geometry of this complex. If we see the hybridized state of this complex ion, all electrons are paired in this case. So this complex ion is diamagnetic in nature because magnetic moment value can be calculated by using spin only formula, that is mu is equal to under root of n into n plus 2. So put the value of n is equal to 0, so that comes to be equal to the magnetic moment value 0. So this is diamagnetic in nature. Now we go through the another square planar complex AuCl4s2 minus. Here the chloride in the strong field ligand, and we calculate the charge on Au, that is aurate. Here are the 4 chloride ions present here around the aurate. Here are the 4 minus charge. What is the charge on Au? So here we take the plus 3 charge on Au minus 4 is equal to 1 minus charge, that is the overall charge on this complex ion. So aurate having the atomic number 79, electron configuration is 4f14, 6s1 and 5d10 in the ground state configuration. So when the metal is form its ion, that is Au3 plus, ultimately there are 3 electrons are lost from this valence shell. So ultimately the configuration is 4f14, 6s0, 5d8. So loss of 3 electrons from the s shell and the d orbital. So here in the electron configuration of this ground state, we can feel the electrons, and in the excited state this electron will be pair up over here in previous d orbital, and make one orbital d orbital vacant for the occupation of the electrons of the chloride ions. Here we feel the 4 electrons of the chloride in d orbital and 1 s orbital and 2 p orbitals. So there are 4 electron pairs of the chloride filled in these orbitals, and it undergoes or utilize 1d orbital, 1s orbital and 2p orbitals, giving rise to dsp2 hybridization in this complex. Now next geometry is trigonal bipyramidal. So trigonal bipyramidal having dsp3 hybridization. Now take an example of trigonal bipyramidal geometry FeCO5. Here the carbonyl group is a neutral ligand which is surrounded to the Fe. So ultimately what is the oxidation state of Fe? That is 0, because CO is a neutral ligand or carbonyl is a neutral ligand. So here atomic number of iron is 26, configuration is 4s2 and 3d6. Here is the 6 in the free ion or atom, and now we can feel these electrons in the excited state. So here are the total 8 electrons are present in this excited state, ground state of the, and excited state becomes the same. So all these electrons are here we can feel likewise, and after that the 5 electron pairs of the 5 carbonyl groups into 3d orbital, 1 4s orbital and 3 electron pairs in 4p orbital. So occupied by these 5 carbonyl ligands into these Fe orbital, that is a 3d, 4s and 4p, and it undergoes dsp3 hybridization because 1d orbital is utilized, 4s and 3 4p orbitals are used, hence dsp2 hybridization. If we see the geometry of this complex, Fe is present at the center of the particular triangle, so that is called as a trigonal, and there are 2 ligands which are present at the pyramidal position, upper side and lower side. So in this way this is a trigonal and there are 2 pyramid at the top and bottom. So the geometry is trigonal bipyramidal, undergo dsp3 hybridization. And if we see the hybridized state of this complex, all electrons are paired, hence it is diamagnetic in nature, and it has 0 magnetic moment value. We try about the another example, CuCl5 raised to 3 minus charge. So what is the electron configuration of the copper? Copper having the atomic number 29, its electron configuration is 4s1 3d10, and the orbitals of the particular copper is like this 3d, 4s and 4p. So we can feel the 11 electrons in this way, that is 5 electron pairs, that is 10 electron, and this is 4s electron we can feel in this orbital. Now in this orbital there is a Cu2 plus ion. So copper having the 2 plus charge because chloride having the minus 5 charge, and overall charge is 3 minus. Ultimately copper has plus 2 minus 5 is equal to overall charge is minus 3. So here copper having the oxidation state plus 2, and the electron configuration in this copper 2 plus is 4s0 and 3d9. So we feel the 9 electrons in the ground state electron configuration of this excited state. Now here we take the 4d orbital because we required the 5 orbitals vacant of copper for the filling of the electrons of the chloride ion. So we need the 4d orbital here, and only here we use the 4s, 4p and next 4d orbital for the occupation of the electrons of chloride ion. So we fill the 5 electron pairs into these vacant orbitals of the copper. Here one pair in 4s orbital and another is 4p, and 3 pairs actually, and 4d having 1 pair, and it undergoes what type of electron configuration, that is the hybridization. DsP2 hybridization is involved. Actually sp3 d orbital. So here we have to use the next d orbital. Here we having sp3 dehybridization, mind well. So there is a certain change in the configuration or filling of the electrons, and it has sp3 dehybridization, mind well. And now what is the geometry of this complex again? So it is a trigonal bipyramidal. Central metal atom is copper, and 5 chlorides are arranged likewise, 3 at the triangular face and 2 are at the apex and bottom side, and it undergoes trigonal bipyramidal structure, and it undergoes sp3 dehybridization. So now what is the magnetic nature of this complex? Here is paramagnetic, because in this hybridized state there is one electron is unpaired. So we use again the particular formula to calculate the magnetic moment value. Mu is equal to under root of n into n plus 2. So put the value of n is equal to 1. So ultimately that comes to be equal to 1.73 Bohr magneton. This is the magnetic moment, and it is paramagnetic in behavior. Next example is trigonal bipyramidal, and again nickel having the atomic number 28, configuration is 4s2 3d8, and we see the nickel having the particular charge. So here is the electrons we can feel here, 8 electrons, and the Ni3 plus ion, by losing 3 electrons from the nickel, ultimately Ni3 plus ion is formed. So there are 7 electrons. We can feel the 7 electrons likewise in the d orbitals. And now these electrons make a particular electrons into the previous d orbital, and make one d orbital for the occupation of the electrons of the cyanide in this case. So there are 5 pairs of the cyanide can be filled into one d orbital, 1 pair into the 4s orbital, and 4p orbital having 3 pairs. So in this way there are 1, 2, 3, 4 and 5 electron pairs of the cyanide filled into these orbitals, and it undergoes dsp3 hybridization. And even we study about the particular orbit, that is the shape of the orbital and the geometry. We say that is nickel at the center, and 5 cyanide ions are arranged in this way. That is a triangular face, there are 3, and apex and bottom side are the 2. Ultimately it undergoes the particular trigonal bipyramidal structure and dsp3 hybridization. So here the particular magnetic moment value of this complex is again 1.73 bm, because it is a paramagnetic in behavior. Thank you. Bye bye. Take care.